I have started a recording. So let's share the slide. Can you see the screen? I think it is visible, right? That's great. So today we'll discuss about uh, soil that considered as a three-phase system in nature. Time. So can you see this? Can you see this? I think it is visible, right? Okay. Yeah. So I'll just put on the slide. Yeah. So today's class will discuss about three-phase system of soil, okay, and also some relation in terms of volume. So we'll discuss in detail. Okay? So I think in the previous class we have already mentioned, I have already mentioned that soil is considered as a complex material, okay, and originally found from a rock, okay, and it contains mainly three components, okay. The soil mass in nature is said to be made of three components. One is what? Soil solid or soil particle, water, and air. Okay. So here the statement is written here. You can see a soil mass is a three-phase system consisting of soil solid or solid particles, soil solid or soil grain, whatever, same thing. Okay, and water and air. Okay. So next, let's discuss about this statement. Okay, we can elaborate this statement in graphically. So can you see this diagram? I think it's visual, right? Let me do the full screen here. Okay, now I think it will be more clear. Okay, so I think you can see the slide, right? So let's concentrate on the first diagram. Okay, this. Let me put on the pen. Wait. Okay, so first see this one, this diagram. So here, this is a representation of soil which actually exists in nature. Okay, and this is a microscopic view. So you cannot see this naked eye, but yeah, if you zoom in the soil mass, you can uh, it, it can possible to see this kind of structure. Okay, so here you can see some uh, unsimilar or different border line, isn't it? Different blocks are there of irregular shape. Okay, some are small, some are tiny, some are larger, isn't it? And having different shape and size. So these blocks are represents what? Soil solid. Here you can see written here soil solid. Okay, great. So it is a soil solid. So these irregular size and shape, okay, these are represent soil solid, actually soil particles. So among these soil particles or among these soil solid, some gap may be generated, vacant space. Okay, so this space, like you can see, this one is a vacant space, which is here also, and this is also some vacant space. Okay, here also. So small or larger, there are many vacant space may be available here. You can see in the soil mass. Okay, so these gaps or vacant space are known as voids. VOIDS. Okay, fine. So these voids may be filled sometimes by air or by water. Okay. Now let's discuss how can the voids may be filled with air or water. Okay. So let's take an example in a example of rainy season. Suppose this is a ground surface. The ground surface. Okay. Now in suppose in rainy season, what will happen? Rain will penetrate into the ground. Rain will come and it will pass through the ground surface and it will percolate into the soil, isn't it? So what will happen? For this vacant space that we already mentioned, they are known as voids. These voids may be filled with water. Okay, that means whatever voids from here to here. Suppose we are considering only up to this depth, from ground to here. So if you consider only this depth, the whole voids will be filled up with what? It will be filled up with water. Okay, so this can be represented by this diagram. Okay. Now, what about this? All these three diagrams. These are the representation, simplified version or simple representation of a natural soil, so that we can understand the different relations. Okay. So in nature, they all are exist in a like a mixture, soil solid and voids may be filled up with air or water. Okay. Now, to for better understanding, what we have done, just for understanding, we have just separated all these three components. Okay, all these three main components of a particular soil. It is soil solid, we're putting at the bottom. Then above soil solid, we put whatever amount of water will be there, just put the water here, and then air. Okay, now suppose uh, just little bit of for a very small time interval, water came. Just for example, okay. Suppose for small time of interval, water came, and only up to this depth. I'm just giving you this example, okay. So just say, wait, yeah, only up to this level, uh, up to this level, soil is saturated, or you can say the voids are filled up with water. Okay, then after that, rain stopped. Okay, that means what? Below this level, that means below this level, up from here to here, the whole voids will be filled up with water. Okay, and maybe the soil which is above this level, above this groundwater, or above this groundwater level, these voids may be filled up with air. Okay, that means this scenario can be represented by this first diagram. Okay, that means in this particular soil mass, it contains soil solid, also water, as well as which air also. Okay, now this is your soil solid part, and this is whole represents void. Okay, so this void may be partially filled with water and partially filled with air. Okay, so if this is the case, this kind of soil may be known as partially saturated soil. Fine. Now saturation means it's related to the presence of what? How much water is present in the void. Okay. Partially. Partially means what? Not fully. Partially means any percentage will be there, less than 100%. Okay. So if the rain fully come and for a longer period, if rain comes and suppose water level is rising up to this ground level, and now this water reaches up to this level, then what will happen? What will happen? The whole void will be filled up with water. Okay. Then that case will be represented by this second diagram. That means the soil solid part will be remain same because we cannot remove soil solid. Soil solid part will be remain same. In diagram also you can see the height of the soil solid is constant here, even here also. Okay. So this soil solid will remain constant. For we're talking about a particular cross section of a soil mass. Okay, but the volume of void or whatever the area or volume occupied by the void, this may be fully occupied by water. Whole vacant space, whole void will be filled up with water. Then what will happen? This air will come out of the system, and in the place of air, this water is increasing, and the water will take the place of the air, and it will reach up to this level. Okay. So if this is the case, if complete the whole voids will be completely filled with water, in that case, that type of soil may be known as fully saturated soil. Saturated, I already told you, saturated related to the presence of water. Now, what do you mean fully? 100%. That means full void. All the voids will be fully occupied by water. That's why it's called fully saturated soil. Okay. Now come to the third case. Now let's take an example of a dry season. In dry season, what will happen? The water will get evaporated. And say, take an example, whole voids are get evaporated and whole water gets expelled out from the void. Then what will happen? Whole voids will be left with air only. Okay, because if previously it was taken by water, then now water will come out. Suppose, okay, then that place will be taken up by air. So in that case, what you can say, the soil mass, in the soil mass, the whole voids will be filled up with air. Okay. Now, if there is no water, you can say it's a dry soil. It's a very simple definition, right? It is very dry soil. So whenever we heard this term dry soil, that means you have to understand the voids are occupied by air only. So there is no presence of water. Okay. Have you understood till now? And I'll take some response if you understand. You can just respond in chat box. Till now, do you have any doubt? You can ask me about this three-phase system of soil. You can write in chat box. If you are clear about this, if you don't have any doubt, you can just respond here in chat box. Did you understand? That is, we have already discussed. Okay, I just want some response. Okay, write in chat box. समझ में आया कि नहीं आया? अगर आया तो we'll proceed to the next content. Okay, अगर नहीं आया तो I can repeat it for some time. Okay, good, very good. I think it will be very easy to understand. Okay, so mainly based on presence of water or based on three-phase system, again we can divide soil in three types. Okay, so what are the three types of soil? Partially saturated soil, fully saturated soil, and dry soil. Okay, I think it will be clear to you. Okay, great. So we'll proceed to the next. Wait. Yeah. Yeah. So here you can see again the same diagram, a schematic diagram of three-phase system you can see. And this is the case of what type of soil? Can you tell me? This phase diagram is representing what type of soil? Can you write in chat box? If in a particular soil mass, what? Partially saturated soil. Good, very good. So this is a case of a partially saturated soil, since the voids are partially filled up with water and air. Okay, great. So here you can see some symbols are given, volume symbols and weight symbols. Why we have given? So based on volume and based on weight of a particular soil mass, we can derive some definition or we can derive some relation. So to understand that relation or that definition, we need to understand this thing. Okay. So first we'll go through the volume symbols. Fine. So this is the case of partially saturated soil. We are taking an example of a partially saturated soil. Now this capital V, let me take a pen. So this capital V represents what? It is starting from here to here. So this represents volume of
Total volume.
soil mass. Okay. So total volume of soil mass. Suppose capital V represents total volume of soil mass. Okay. Now capital V with suffix S. So Vs represents volume of solid. S stands for solid. So it is, that's why from here representing from here to here. Okay. Now from here to here, it represents what? From here to here. Here to here represents the volume of void. Okay. It represented by V. So capital V with suffix V, VV represents volume of void. Now this volume of void, in case of partially saturated soil, it is summation of what? It's a summation of VA and VW. So VA represents volume of air and VW represents volume of water. Fine. Now if this is a case of a dry soil, what will happen? In case of dry soil, DS will remain constant since solid will remain constant, but this volume of voids, this whole voids will be filled up with air, isn't it? In that case, VV is directly equal to VA in case of dry soil. Okay. Now, for fully saturated soil, what will happen? For fully saturated soil, whole voids will be filled up with water. That means in place of air, it will be taken up by water. Then VV, that is volume of void, will be equal to VW. Fine. I think it is clear, right? Now let's go to that weight symbol. Now let's start from this weight of the solid. Now WS, capital W with suffix S, it represents what? Weight of solid. Okay, weight of solid. Sometimes it is also known as weight of dry soil because this solid, there is no presence of water since we have just separated out all these three components. So we can also sometimes, it is also known as dry soil or weight of dry soil. Okay. Now from here to here, we can say weight of voids. Okay, but before that, let's go back, go to here, weight of water. What is weight of water? Denoted by W by, sorry, capital W with small w. Okay, so W represents weight of water. W air, WA, okay, WA represents weight of air. Fine. But in this case, this WA is so negligible, so it is very small and we can neglect it. Okay, this WA, that is weight of air, can be negligible. So indirectly, what we can say is weight of voids, WV, can be represented by weight of water alone. Fine. I'm repeating again. So weight of void, WV, weight of voids can be represented by this weight of water alone since WA can be neglected. Okay. So if this is the case, the total weight, if you want to find out total weight, W, capital W, this capital W will be very strong here to here only, not up to this level. Okay, not up to this level, up to this level only. Since WA is negligible. Okay. So here capital W can be, it's a summation of WS plus WW. Okay, clear till now? Okay, so today we'll discuss very some of the relation based on volume. Okay, so I think these symbols relations, I think it is clear to you. So let's go back, go to the next slide. Okay, so let's discuss this wet list relation in terms of volume. Okay, and weight. So relation in terms of weight we'll discuss in the next coming classes. So today we'll discuss only relation in terms of volume only. Okay. So first relation in terms of volume, which is what? Say void ratio. Fine. So what is void ratio? You can, I think you can see void ratio. It is the ratio of volume of voids denoted by VV to the volume of soil solid. divided by Vs, and it is expressed as a decimal or fraction. Okay? And mathematically, it is represented by uh, this that relation. Okay, and it is void ratio is denoted by small a. Mind it. Okay, void ratio it is denoted by small e, and it is a ratio of Vb by Vs. Now, what is Vb? Volume of void. Vs is what? Volume of soil solid. Now, let's go back to the diagram. Let's discuss again. So, what is E? Wait, so, if we want to find out E, void ratio for particular dish soil, what will happen? E will be, it is a ratio of what? This volume of void divided by volume of solid. So, this volume divided by this volume, if, by dividing this volume by this, you will get void ratio. Okay. Okay. So next we'll discuss porosity. Porosity is denoted by small n. Okay. So small n, by definition, it is the ratio of volume of voids to the total volume of soil. Total volume of soil. Okay, mind it. Denoted by capital V, and it is expressed as a percentage. Why? Because it is multiplied by 100 again. Okay. So I think you can see the mathematical representation. Small n is equal to V by capital V multiplied by 100. Okay. Now I think you can see the similarity and difference between these two relations. Okay, it's very almost similar. Okay. So don't be confused with void ratio and porosity. In terms of void ratio, so VB is divided by VS. But in case of porosity, VB is divided by capital V. Okay. So let's go back to that. So let's go back to that. Yeah. So I think so here you can see, if you want to find out porosity, that is small n, how can you find out? By just dividing this volume of voids by this total volume. Okay. Multiply by 100. Okay. So I think it is clear to you, void ratio and porosity. And since they are almost similar, they can be correlated or interrelated. So void ratio and porosity are interrelated to each other by this following relation. Okay. So E, if you know porosity, that is small n, for a particular soil, you can find out void ratio for that soil by using this relation. Okay. Or suppose you know void ratio for a particular soil, you can find out porosity by this relation. Or you can use on this one also. Okay, they are just same. They're just representation of interrelation. Okay, so it's better to remember this relation. You can remember this one. Okay, so in some competitive exam also this relation may ask. It is very important relation between void ratio and porosity. I think it is clear, right? You can write in chat box till now. Is it clear? If you have any doubt, you can ask me. Do you have any doubt till now?
Sure.
Okay, clear, right? I think it is very easy to understand. I believe I think you can
Yes,
understand.
sir.
Okay, good. So let's go back to the next one. Yeah, I think I can see this slide. So number three, third relation is what? Degree of saturation. Degree of saturation means how much water present in what? In basic definition, it is what? Degree of saturation mainly about to know the amount of water present in void. कितना पानी है void में, वही जानना ही degree of saturation. Okay. So here you can written here. So volume of water in soil can vary between 0, that is a dry soil, and the volume of water. We'll discuss later on. Okay. This can be expressed as a degree of saturation. Whatever definition is not clear here, so I'll just explain it here. So degree of saturation, what is this? It is defined as a ratio of uh, volume of water present in the void to the total volume of void, not total volume of soil. Okay, mind it. And it is also expressed in terms of percentage. So I want to repeat again. So what is, and also degree of saturation represented by capital S. Okay. So degree of saturation, it is defined as a ratio of volume of water VW to the volume of void dV multiplied by 100. So let's go back to that diagram. So if you want to find out degree of saturation, how can you know the volume of volume of water divided by volume of void. That means in this volume of void, how much water present? That implies degree of saturation. Okay, and it varies from the value of degree of saturation varies from 0 to 1. How can we say this 0 to 1? Okay, now see, when this degree of saturation becomes 0, कब 0 होगा? जब ये VW becomes 0. Okay, if we put VW as 0 and whatever the value of this VB, but forget about this, ignore this. If you put VW as 0, then automatically S becomes 0, isn't it? So now question is, when VW becomes 0, VW is 0 means what? There is no water. That means it's a dry soil. So in case of dry soil, VW will be 0, and for the dry soil only, S will become 0. Okay. Now, when S become 1, if we put VW is equal to VB, then what will happen? If VW becomes equal to VB, that means they will be cancelled out, and finally they will become 100%, or in that you can say 1. So when it will be happen that VW become equal to VB, that means all voids must be filled with water. That means this is a case of fully saturated soil. Okay, so in case of fully saturated soil, VW equal to VB and S become 1. Okay, now in that means we can say for dry soil S equal to 0 or 0%, and for fully saturated soil S is equal to 1 or 100%. So in some exam you may ask, or in Viva also you may ask, that what is the range of S? What is the range of degree of saturation? So you have to answer that S may be vary from 0 to 1. Okay, it cannot be less than 0, or it cannot be more than 1. Okay, so degree of saturation value, this value cannot be more than 1. Okay, so I think it is clear to you. Next, come to the 4 and 5. I think it will be similar. Air content and percentage air void. Okay, so air content, it is denoted by AC, small a c. Okay, so it is the ratio of volume of air to the volume of void. It's simple. I think I don't need to explain this thing. I think it will be very simple. So in mathematical representation is what? AC is equal to dA by dV. So okay, dV, that is volume of air by volume of void. How much air presents in void? That represents air content. Okay. Now percentage air void, it is denoted by small na, percentage air void. Okay. So it is the ratio of volume of air to the total volume. It is percentage air void means it is expressed in percentage. So that's why it is multiplied by 100. And the ratio is what? dA by capital V. It is volume of air by total volume. Now you can see the similarity and difference. Air content, in case of air content, volume of air is divided by volume of voids. In case of percentage air voids, volume of air is divided by total volume of soil, also multiply by 100. Okay, and you can see this is the interrelation between air content with percentage air voids. Okay, so you can see this n represents porosity multiplied by AC. Okay, so if you put the value of n and if you multiply by AC, you will directly you will get this value. This is percentage air void. You can do it by yourself also. Okay, you take the relation of porosity and multiply by the air content, you will get percentage air. That's why we can get this relation Na is equal and multiply by AC. The relation between porosity, air content, and percentage air. Okay, so you can just note it down. Fine. So I think till now we have discussed what you discussed till now. So we have discussed about phase diagram of soil. So in nature, soil may be in a three-phase system, maybe two-phase system. Okay. So this diagram, it is in a two-phase system. Okay, because the voids filled with water only, as well as this diagram also. So this dry soil also, you can say this is in a two-phase system because it contains solid and air only. Two-phase. Only partially saturated soil is considered as a three-phase system because it contains solid, water, also air. Okay. So in some viva or in some question or in some exam maybe ask you that like fully saturated soil is in which state? What phase that? What phase? Okay. You may given some option also. One phase, two phase, three phase like that. So you have to know fully saturated soil is filled up with water. Okay, so that's why it is two phase system. Dry soil also two phase system. Only partially saturated soil is a uh, three phase system. Okay, so based on this, we have derived some relation based on volume and weight. Okay, so for this class, we have discussed some how many five relation, that is void ratio, porosity, degree of saturation, air content, percentage air voids. Okay, so these five relations are based on volume of a particular soil. So next class we'll discuss about some relation in terms of weight. Okay, do you have any doubt till now? If you have doubt, if you have doubt, you could ask me now, or I'll just stop my
No, sir.
recording. Okay, okay, I'll stop my recording now.